This is the video for lesson 121. It's on page 490, and it's rational inequalities. So we've had inequalities with second degree equations, quadratics, with absolute values, linear functions, and ones that were on a line where you just had an x, right? Now we're going to have rational functions, and there's going to be something very important that you remember with rational functions. So a rational function looks something like x plus 2 over x minus 1, maybe less than or equal to 0. All right, when you first look at the function, you have to look at the denominator. Remember, the denominator can never equal 0 because then the fraction is undefined. So that's the first question you answer. What can x not be? What value can x not equal? And that's whatever value that would make the denominator equal to 0. In this case, it would be 1. X could not equal 1. All right, so that's the first thing. Denominator cannot equal 0 because then the fraction is undefined. The second thing you have to take note of is normally with inequalities, when we have a fraction, remember with equalities, we eliminate the denominator. We're going to do the same thing with inequalities. However, we have to contemplate, what if the denominator, the value of that denominator, the value of x minus 1 is negative? Because remember, in inequalities, you multiply or divide by a negative value, it changes the direction of the sign, the inequality. So in order to remedy that and know that what we're multiplying by is a positive number, we're going to square the denominator. So we're going to multiply every term by the denominator squared. So in this case, it would be we'd multiply by x minus 1 squared. Because even if the denominator is negative, once we square it, it's a positive value, right? All right, so let's look at example 1 in your textbook. It wants us to graph 1 less than or equal to negative 1 over x minus 4. The domain is all real. So the first question we must answer is, what can x not equal? It's what would make that denominator equal to 0. So x cannot equal 4. The value of x cannot be 4 because when it is undefined. Now, we multiply every term by that denominator squared. So on both sides, we're multiplying by x minus 4 squared. On the right-hand side, the denominator eliminates and one of those terms eliminates. So we're just distributing the negative 1 to both of the terms in the binomial. So we have negative x plus 4 on the right-hand side. On the left-hand side, we just have x minus 4. That binomial squared times 1. 1 times anything is the other thing, right? So let's just do x minus 4 squared. And that's x squared minus 8x plus 16. Now we're going to set this equal to 0, and we're back at a quadratic inequality. So we add x on both sides, subtract 4 on both sides, and we have x squared minus 7x plus 12 less than or equal to 0. Less than is a conjunction, right? It's going to be all in the middle. We factor x squared, the quadratic, and so we look at factors of positive 12 such that we add them and they equal negative 7. So it's x minus 3 times x minus 4 less than or equal to 0. All right, in order for those to be less than, remember we have to have plus and minus or minus and plus. All right, the factors must be plus, minus, because we have to have a negative value for it to be less than 0, or negative and positive. All right, so for x minus 3 to be positive, it has to be greater than or equal to 0. For x minus 4 to be positive, negative rather, it's got to be less than or equal to 0. All right, let's work this side. Remember, with the less than, we're choosing the one side that works. So when I add 3, can x be greater than or equal to 3, but less than or equal to 4? And it can. Except, remember, right, x cannot equal 4. So we don't even have to work this side because this side works and makes sense, right? The values that are above 3 are also below 4, and it is a conjunction. So if I graphed it, it's just the values from 3 to 4, but because of this denominator, my indicator on 4 is going to be open, but on the 3, it's going to be closed. All right, so now let's look at example 2 in the book. All right, it says graph m minus 2 over m plus 2 less than or equal to 2. All right, first question we answer is, what can m not equal? And if it's negative 2, that denominator is 0. So m cannot equal negative 2. I will remind myself that when we get to the end and we're graphing the set of solutions. All right, because I don't know if that denominator is a negative value when I take m and combine it, add it to 2, I must multiply both sides by m plus 2 squared on both sides. On the left, the denominator eliminates and one of the terms eliminates, and I just multiply m plus 2 times m minus 2. They're conjugate terms, so I'm just going to multiply the first and the last. So I end up with m squared minus 4 less than or equal to. I'm going to go ahead and figure out what m plus 2 squared is, then I'll distribute the 2 to all of the terms. So m plus 2 squared is m squared plus 4m plus 4. Then we distribute the 2 to all of the terms. So that's 2m squared plus 8m plus 8 plus 8. All right. I'm going to move everything to the left because that's what we're accustomed to seeing. And I'll end up with a negative m squared, but then I'm going to multiply everything by a negative 1, so it will change the direction of the signs. All right, so I'm going to subtract 2m squared from both sides. I'm going to subtract 8m from both sides, and I'll subtract 8, leaving it less than or equal to 0. So I have negative m squared minus 8m minus 12. Okay, I don't want that negative. So I'm going to multiply every term by a negative 1, and I'm going to change the direction of the sign. So this is now going to be a disjunction because it's greater than. So we have m squared plus 8m plus 12. Now what are factors of 12 such that we add them and they are equal to 8? Well, that is 6 and 2. Now this is a disjunction. So either both of them have to be positive, this term and this term have to be positive, or they both have to be negative. And we're going to take one from each side for the disjunctions. Remember? Okay, this is new. All right, so they're either positive and positive. I'm going to erase some of this and work up. Reminding myself m cannot equal 2. So they're either positive and positive or negative and negative. All right? All right, so for m plus 6 to be positive, it's greater than or equal to 0. M plus 2 to be positive, greater than or equal to 0. Remember, on the greater than side, we're choosing the largest number. On the negative side, the less than side, we're choosing the smallest number. All right, so for m plus 6 to be a negative value, it has to be less than or equal to 0. The same with m plus 2. less than or equal to 0. Solving these inequalities for m greater than or equal to negative 6, m greater than or equal to negative 2. Negative 2 is bigger than negative 6. Every number that is greater than negative 2 is also greater than negative 6. But not every value greater than negative 6 is greater than negative 2. So that's why you're choosing on the greater than side, the positive plus side, you're choosing the largest number. On the right-hand side, it's going to be m less than or equal to negative 6, m less than or equal to negative 2. On this side, you're choosing the smaller value because every value less than negative 6 is also negative 2. And it has to satisfy both of them. Now, reminding myself, x cannot equal negative 2. When I graph this, there's negative 2, like 0, here's negative 6. So greater than or equal to negative 2, it can't equal it, right? You've got to remember that because it can't. When you graph it, it doesn't equal it. That denominator makes it undefined. Less than or equal to negative 6 goes in this direction, and that one is a closed indicator. Okay, that's a closed interval. All right, that's it for this lesson.